Yeah, hi, all. Good morning. So let's get started. So today we'll be discussing a new data structure, which is stack. It means last in, first out. So this is the idea how a stack behaves. So this is how we define a stack. So what operations can be there? So these are the 5 major operations: how to push an element to the stack, how to pop an element from the stack, how to see the top element in the stack, how to. Let us try some more examples to understand more how the stack behaves. So let's say with the output pattern 30, 22, 5, 3. Most there's no doubt, then I'm okay. Yeah, hi, all. Good morning. So let's get started. So today we'll be discussing a new data structure, which is stack. So what happens in a stack is it is data structure which performs LIFO operations. So how we can understand what is a stack? We can just say it is behave like a box. It is a box which is closed at one end. Okay. On a high level, you can say something like this, and it performs the LIFO operations. What is LIFO? L starts for last, I starts for in, F starts for first, and O for out. Okay. It means last in, first out. Okay. Let's say you have 10, then you added 20, then you added 30. Then so let's say you keep on adding the elements. Okay. So what you did first is that you added a 10, correct? Then you added a 20, then you added a 30, then you added a 40. Now, if you have to remove the elements, so the elements will be removed in this order only. Because see, this end is packed. This place is packed. You cannot remove the elements on the bottom. It can only be removed from the top. Correct. So this is the way how the stack behaves. You keep on pushing the elements 10, 20, 30, and 40. And when you have to remove, it will be removed from the top. So what elements should, so if you remember, the first element that we pushed was 10. But the first element which will be removed will be 40 only. Okay. This is the idea because you have to remove 40, then 30, then 20, then to remove 10. You cannot actually remove a 10. So this is the idea how a stack behaves. Now, let us see how we define a stack. So we can just say, like, specifically if we talk in Java, so how we do it is that we write stack, and here we write an integer of type st is equal to new stack integer. Correct? So this is how we define a stack. Now, what else we see? Now let's say we have defined this stack. Now let us perform some operations on stack and let us see how we get the output. But before that, let us understand what are the operations or the function which the stack has. So let's say we have defined a stack of name st, correct? So what operations can be there? So the first operation which we can check on the stack is how we push the element of the stack. So there we can just write stack.push and the element itself. So let's say we want to push 10. So I will write stack.push 10. What this will do, this will push the element into the box. Okay. The very first thing, the push operation. We are talking about the operations which can be performed on a stack. Okay. No, it is fine. Second thing can be pop. Okay. So pop is the operation. Here we don't give any specific element because obviously it will pop from the top. So that is fine. This is how there are two operations, push and pop, the two major operations. The third that is normally used is the peek. So what is peek? So let's say you have a stack something like this, 10 and a 20. Okay. Now if you do the pop operation, now if you want to see what is the latest, what is the element which is at the top of the box. Now for checking that, you have to do the peek. So if you do the stack.peek, you will get something like 20 here. Stack.pop will also give you 20, but what will happen is this element is not removed from the stack. But in peek, the removal is not there. It just tells you. So you can say in stack.pop, the removal is there. Here the removal is not there. It just tells you what is the top element in the stack. So anytime if you have to find the top element in the stack, you have to do stack.peek. Moving forward, what else we have? We have something called isEmpty. Stack.isEmpty. Normal thing that how we have in other data structures. Stack.isEmpty just gives you a true or a false. If the stack is empty, it will give you a true, otherwise a false. So only two operations are supported here, a true or a false. So this is how stack.empty behaves. Let's see other things. So one more operation can be there is stack.size. So here, if someone wants to find the size of the stack, you can write this operation similar to what we have in arrays, correct? In arrays, we have something like arrays.length, arr.length, correct? Similar to what we have in string, str.length, correct? Similar to this, we have in array, stack.size. This will give you the size of the array. Okay. So these are the 5 major operations: how to push an element to the stack, how to pop an element from the stack, how to see the top element in the stack, how to see the stack is empty or not, and how to find the size of the stack. And this is how we define a stack. Stack integer, ST will new stack integer. Normally, the how we define other data structure as well. So this is pretty much it. Let us try some more examples to understand more how the stack behaves. So let's say what happens is, okay. So let's write some operation. Let's say, and you guys need to tell me the output for them. So let's say we have defined a stack of name S, and we do something like this: S dot push 10, stack dot push 20. Then we have stack dot push 30. Okay, now the pushing is done. Now we want some outputs. So let's try to print stack dot p. Okay, we are trying to print stack dot p. Now after what we are doing s dot pop, but we are not printing it. After this, what we are doing again? We are again printing stack dot p. After this, we are printing stack dot size. Okay. After this, we want to push a new element. Let's say we want to push a 5. And again, we will do 2 more operations similar to what we have above. Like we will print stack dot p, and we'll print stack dot size. Okay. So this is the one. I want you guys to give me direct message the output for these 5 in this order. First output will be for this, second will be for this, then this. What should be the output if you print this? Okay. Push, as you know, will give you will push the elements in the stack. Peak will give you the top element. Size will give you the size of the stack. Pop will remove the element from the stack. So follow this order and give me the output of this. Yeah. So how it is? Let us see. So let's say this was our stack. Okay. So this was a box. Okay. What happened is we have pushed 10. Now 10 is in the stack when you push the first element. Now this is what happens here. Now 20 is pushed. 20 will be here. Okay. 30 is pushed. 30 will be here. Okay. This is what we have as of now. We want to find the peak element. What is the top element? Top element is 30. Okay. So first output will be 30. Because most of you are correct. Then we do stack dot pop. What happens in the pop? We remove the top element. Now 30 is no more our top element. Our top element now becomes this 20. 30 is no more our top element. This 20 is our top element. Okay. Again we do stack dot peak. Again we find the top element. This top element, it is 20. We are looking for the size of the stack. The size of the stack is 2. So it will be 2. 2 elements only. Then we are pushing s dot push 5. We are pushing now 5 to the stack. So stack is now something like this. We are trying to find the top element of the stack. Top element is again 5. And then we are trying to find the size of stack, which is 3. Okay. So this will be the output pattern: 30, 22, 5, 3. If there is no doubt, then I'm okay.